Okay, finishing up this example then, a particle's movement is modeled by this equation. So they're modeling a particle and it's following a cubic motion. Okay, so its motion is modeled by a cubic. So we want to answer the following. So what you can do, the shortcut really for this particular section is you can go ahead and what I do off to the side in my rough work, I actually go ahead and find all the equations. Because the odds are, especially on a test, I'm going to be asking about displacement, velocity, acceleration. So I just go ahead and I do all the calculations. So 6t squared minus 12t plus 16. So there's my equation for velocity. And acceleration is 12t minus 12. Displacement should be a vector as well if I want to be completely accurate. So there we go. So now I can actually, technically, I'm going to start answering A. So A part. What is the displacement after 2 seconds? So displacement after 2 cubed minus 6, 2 squared, plus 16 times 2 minus 5. And just threw a bracket on there, just for the heck of it. And of course, the dumb board's having a hard time figuring out what I want to do. So when you go through and calculate, you get 16 minus 24 plus 32 minus the 5. So equals 19 meters. So therefore, the displacement is 19 meters forward. So the displacement is 19 meters forward, and there we go. So I'll just do some housekeeping here. All right, on to B part. So B part asks, what is the instantaneous velocity? So a bit of a dead giveaway. We are looking at the velocity equation. And what is the velocity after 2 seconds? So we're just plugging 2 into the equation and solving. So we end up with 24 minus 24 plus 16. So that's 16 meters per second. So therefore, velocity will be 16 meters per second forward because it's a positive value. C part, what's the acceleration? So you start to see that the challenging or the actual calculus part is this right here. Okay? Once you've done that, calculus is over. Now it's just kind of interpreting what information they want. So we get 24 minus 12. So we end up with 12 meters per second squared. So therefore, acceleration will be 12 meters per second squared forward. D part. What is the acceleration? When is acceleration 0 meters per second? So when is acceleration 0 meters per second? We're going to let A of t equal 0. So 0 will equal the acceleration equation. We're just solving for time. So we get 12 equals 12t, or t equals 1 second. So therefore, after 1 second, acceleration is equal to 0 meters per second squared, just to make sure it's all clean. And finally, E part. What time frames is the particle moving forward and backward? So here, we want to know, and this one's probably the trickier of the questions, what time frames is the particle moving forward and backward? So what we want to know is, the tipping point here is when velocity is 0, right? Because when velocity is positive, you're moving forward. When you're moving backward, it's negative. So when it's 0, it tells you when it's making that switch. So we are going to let our velocity expression equal 0 meters per second, and we're going to go ahead and solve from there. So 0 equals 6t squared minus 12t plus 16. We can take or pull a 2 out of it. So we're left with 3t squared minus 6t plus 8. And finally, we want to solve for t. So I always tell people, do a quick check. So I'm going to check roots. So I'm going to use the discriminant test here. So b squared minus 4ac to see whether I got to go ahead and do the whole quadratic formula. All right. So just doing a quick check. Negative 6 squared minus 4 times 3 times 8. So we end up with 36. Take away. It's going to be like 60, maybe 96, I think. 96. Which means that we get a negative 60 for an answer here. So what does that mean? Okay, therefore, there's no real roots. And does that make sense? Well, off to the side here, let's take a look and make a bit of a sketch here. If you look back to that equation here of the parabola, okay, what can you tell me about it? Well, because the t squared is positive, it's opening upward. And if it's no real roots, it means the parabola is up like this. So therefore, it is always moving forward. There's never a negative velocity. It is always moving forward. All right, so when you get into some questions, this one in particular, a sketch is going to be helpful because you may run into a situation, and I'll just do some rough work down here, you know, if your parabola looked like this, then you're moving forward from here to here. So in this region, you're moving forward. In this region right here, because you have a negative value for velocity, you're moving backward. And then over here, you're moving forward. All right. So when you do your factoring, if it does factor, you got to do a bit of a sketch for yourself to make that determination exactly what's happening and when it's happening. Last example. So again, we're given our displacement equation. So 2t cubed minus 48t squared. Determine the velocity of a particle when its acceleration is 0, when that's its displacement. So I got to find when is the acceleration 0, which means I need acceleration. So I better find an expression for acceleration. So in our 48, so that would give us 96t. Acceleration would be 12t minus 96. So when acceleration is equal to 0, 0 equals 12t, take away 96. 96 equals 12t, and it does work out evenly. T equals 8 seconds. So therefore, at 8 seconds, acceleration is 0 meters per second squared. All right. So what is our velocity at 8 seconds then? Velocity is 6t squared. So I don't need to rewrite that. So 8 squared is our time, minus 96 times 8. Yeah, I know the numbers in this example are a little bit larger than we'd like. So 6 times 64 minus 96 times 8. Okay, no calculator on a test. You'd probably just leave it in that form, but we can clean it up. I'll clean it up for you. 384 minus 768. And when you clean that up, it actually turns out to be negative 384 meters per second. So therefore, the velocity will be 384 meters per second backwards. So this is definitely, we're talking about a particle because 384, you're talking about 1,200 kilometers an hour. So you're definitely talking about some particle that's been accelerated, actually not even close to the speed of light. So it is possible, I suppose, for that to go that fast. So there you go. There's velocity and acceleration taken care of for you. They're in separate sections. I don't really care for it. I like on the test it'll be combined together. It saves you a lot of work. However, the homework is in separate sections, and it should be no problem. Good luck.